Hello, everyone. Today, we are going to learn about the gradation theory for mineral mixture composition design. If you are mindful, you may find that the pavement with cement concrete needs to be maintained for a while before it is open to traffic, while the pavement with hot mix asphalt mixture can be opened to traffic when its temperature drops to normal temperature. Why does the strength increase so fast? Okay, let's first learn how to obtain the strength of asphalt mixture. It is composed of the interlocking force between mineral aggregates and the cohesive force generated by the interaction between asphalt and mineral aggregates. The cohesive force is determined by the properties of asphalt and aggregate. I'll introduce them in the asphalt section. However, the interlocking force only relates to the nature of aggregate. Excellent interlocking force usually requires minimum voidage and maximum frictional force between mineral materials. So, how can we minimize the voidage between mineral aggregates? Let's learn about mineral mixtures first. Void and gradation of mineral aggregate are closely related. We've known the gradation of aggregate when learning about sandstone materials. Continuous gradation and gap gradation. Continuous gradation means conducting the screening test on a certain mixture with the standard set of sieves, and the obtained grading curve is smooth and continuous. The blue curve on the grading curve graph belongs to continuous gradation. Gap gradation means the removal of one or more grain grades from a mineral mixture to form a discontinuous mixture. The red curve on the grading curve graph belongs to gap gradation. To express the gradation directly, we often need to draw a graph involving drawing the grading curve. How to draw it? Generally, the passing percentage or accumulated residue is taken as ordinate and the particle size millimeters is taken as abscissa. The particle size is generally expressed by the mesh size. If conventional coordinates are used to draw the sieving curve, then the passing rate of ordinate is fine. However, as shown in Figure A, the mesh size decreases by half, resulting in a sparse front and dense back, which is very inconvenient for drawing and reference. Therefore, technicians have figured out a way. After taking the logarithm of the sieve mesh size, according to half decreasing sieve mesh size, the difference between them is a multiple of log 2. That is equal spacing. As shown in Figure B, it is very convenient to draw such coordinates. This coordinate system only takes the logarithm of the abscissa mesh size, while the ordinate passing rate is still a conventional one. This coordinate system is called the semi-logarithmic coordinate system. At present, the semi-logarithmic coordinate system is still used to draw grading curves in China. How to obtain the smallest voidage of mineral aggregates, that is, the maximum compactness. At present, there are two theories: Fuller's theory and Talbot's theory. Fuller's theory holds that the closer the grain grading curve of a mineral mixture is to a parabola, the greater its density will be. That is, when the grading curve of the mineral mixture is parabolic, it has the maximum compactness. As we all know, a mineral mixture is a kind of non-homogeneous granular material. It is very difficult to reach the parabola required by Fuller's theory, and it is only an ideal curve. Later, another scholar named Talbot thought that the maximum density curve is a theoretical grading curve. The grading curve should have a certain fluctuation range. In the formula, P is the passing percentage. D is the particle size of particles at all levels. D is the maximum particle size. N is the experimental index. Under the ideal condition, N equals 0.5, it is found that when the mineral mixture is applied to asphalt mixtures, the density reaches its maximum when N equals 0.45. When the mineral mixture is applied to cement concrete, the workability is better when N equals 0.25 to 0.45. The gradation range, including dense gradation and open gradation, of the commonly used mineral mixture is N equals 0.3 to 0.7. As shown in the figure, the green part is the gradation range of the mineral mixture, and the middle curve is the maximum density curve N equals 0.5. However, in engineering practice, it is difficult for a certain natural aggregate gradation to meet the requirements of a certain gradation range. We should combine multiple aggregates to make it possible for the prepared mineral mixture to meet the gradation limits. So, what is the appropriate proportion of these aggregates? This involves the mixed proportion design of mineral mixture. Dear students, today we have learned 1. Two types of gradation. 2. The grading curve is drawn in a semi-logarithmic coordinate system, and the size of the abscissa mesh is logarithm. 3. Fuller's theory and Talbot's theory unveil the past and present of the grading curve range.